Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Josie Jayworth, who holds a Ph.D. from Yale in chemistry. How are you doing today?
I'm great. Thanks so much for having me.
Thank you for joining me. So to start off, I wanted to ask, what made you choose your major in college?
That's a great question. So in college, I did major in chemistry. And this is very much in large part to one of my high school chemistry teachers. I took chemistry as a sophomore, and then I took AP chemistry again as a junior, and just really, really enjoyed both the lab aspect and also the kind of applied math. I liked math ever since I was very young, and I really appreciated how chemistry got to use some of that math, but yeah, in a more applied way.
Yeah. So what was your experience like while getting your bachelor's?
Sure. So I got my bachelor's degree at Fordham University, which is in the Bronx, in New York City. It's a liberal arts college and a Jesuit school, so there's a lot of focus on core curriculum. So in addition to my chemistry classes, I came in declared as a chemistry major, but there's a lot of other courses you're required to take there, which I really enjoyed. So you take a lot of theology and philosophy courses, as well as social science. And I ended up actually with a minor in theology by the end of my time there, just because I was interested in enough courses. But Fordham doesn't have a graduate program in chemistry, so all of the courses and research is very undergraduate focused. All of the research that's happening in the labs is done with the professors, and then the undergraduate students are really leading their own projects, which was a really cool experience for me. I joined a lab first, starting my sophomore year, and I worked in that lab for 2 years, and then heading into my senior year, I switched to a different lab. And in the second lab, I was working on this materials project, creating nanowires for use in a type of solar cell, which made me really excited. And I loved kind of this energy science work, which kind of is what then led me into my PhD.
Yeah. So let's get right into that. What made you, first of all, choose to do a PhD? And then what is your research about?
Sure. So I didn't know that I wanted to do a PhD when I started college. This is something I kind of discovered along the way. Again, since Fordham didn't have a graduate program in chemistry, they have others, but not in chemistry. So I wasn't seeing graduate students in labs. So I didn't really know a whole lot about it. But I was on the cross country and track team at Fordham. So I had other teammates who I knew who had gone on to get PhDs. So it was actually in talking with some of them that I learned a little bit more about this. No one in my family had done a PhD before, so it wasn't really something I knew a whole lot about, other than my professors, of course. So it was, I think it was early in my junior year that I realized this is something that I wanted to do. And at first I kind of had absolutely no idea what to do. And I called one of my teammates who had since graduated, was in a PhD program, kind of freaking out, am I too far behind? What's going on? And she was very encouraging and comforting, and kind of talked me through a little bit of the steps. And then I was able to talk more with my professors about how I needed to prepare for graduate school. I was really enjoying doing research, which led me to wanting to do the PhD. And I actually, though, ended up taking a gap year. So following graduation, I went and worked with the Jesuit Volunteer Corps. It's like an AmeriCorps position. So I was teaching in elementary school on a reservation in Montana, which was very different from obviously like my degree, I was teaching gym class. But it was actually during that gap year that I did end up applying to grad school. I found for me that, first of all, I thought this was the best time in my life to go do something sort of completely different. And I also felt like I would have a stronger application if I was able to include my whole senior year's worth of research and also coursework. So I felt like I would be a stronger applicant applying the next year.
Yeah. So what was your experience like while getting your PhD?
I had a great time, actually, which I think is not necessarily always the answer you'll get. But when I was selecting the lab that I wanted to join, I thought a lot about where would I be happy for like the 6 years of a PhD, both in the professor that I worked with and the other people who were in the lab. So I joined Gary Bredbig's lab, which works on Yale's West Campus in the Energy Sciences Institute. Um, I was really excited about the institute itself because it's a multidisciplinary institute. So I was a chemist and our lab was all chemists, but we worked super closely with engineers, as well as like applied physicists, like computationalists, as well as experimentalists, different people kind of from across many different departments at Yale, which I really enjoyed. Um, and I just really appreciated everyone in our group was very supportive of each other. We worked very closely with the postdocs as well as graduate students and professors all together in a way that was very uplifting and not competitive.
Yeah. Can you talk a little more specifically about your research?
Sure, absolutely. So I started yeah, in the Bredvig lab, which has kind of two main focuses in the research that happens in the lab. Half of the lab is like biophysicists, and they're looking at studying photosynthesis as it actually happens in plants. And then the other half of the lab where I was working works on artificial photosynthesis. So how can we replicate this same idea of taking sunlight and water and making sugars or fuel? And how can we do this in a way that can help supplement different parts of the transition to renewable energy? So this is all about kind of how can we store sunlight or solar energy in the forms of chemical bonds, or so we call this solar fuels. So my personal research started off with looking at these different colored materials, and if we could use these as both the light absorber and also the catalyst that can help convert water into oxygen and then hydrogen. Then I actually abandoned that project because while I was trying to do a control experiment for this project, I found a whole new idea, which was kind of cool. So I was working with a specific dye. It's called Bodippy. And I wanted to see if it connected to these other colored materials. And in doing that, I found out that it binds so much better than I would have ever thought to certain metal oxide materials. And so I ended up spending the rest of my PhD looking at this dye Bodippy and how it interacts with metal oxide surfaces, specifically looking at tin and titanium dioxide. It was really cool because I got to work with some collaborators who are theorists. So they were able to model this dye material interactions. I also worked with a bunch of spectroscopists who looked at kind of how do they interact electronically, as well as got to do a lot of electrochemistry and synthesis and things myself.
Yeah. So out of your PhD, what was your first job?
Great. So I just finished my PhD in January. And so from that, I immediately transferred into a role at Yale. So my current job is I'm the Environmental Innovation Fellow at Yale. This is a joint position that exists between the Center for Business and Environment at Yale and then the Sci Center for Innovative Thinking. So my role is to work with students across the university who are interested in environmental innovation. And this can be kind of different forms, from starting to think of ideas to actually like building a startup company and fundraising, all of that.
Yeah. Uh, so what are your future goals?
Oh, what a great question. I don't know. I'm in this role for at least another year and a half. It's kind of like a fellowship situation. So, from there, there's so many things I'm excited about, and I think this opens up a lot of doors for me. So I think having the PhD in chemistry, right, of course, gives me like the technical skills to work in labs and have a pretty deep understanding of the science behind a lot of these like climate technologies, specifically thinking in the fuels and energy spaces. So I'm not sure. I'm excited about maybe working with some of the startups who I get to be introduced to through this job, or perhaps other roles in the ecosystem. All I know is I definitely want to be working in the energy transition, and working on, yeah, some sort of climate job.
Yeah. So when someone gets a major in chemistry or physics, I know that there's like a whole wide range of job possibilities and areas to work in.
Mhm.
Because of that, do you think it's much more necessary to have either a master's or PhD so you can specialize compared to other fields?
That's a good question. I think not necessarily. I think it depends a lot on what you want to do. I do think that if you're going a more traditional route, like working at a big company, it is helpful to have some sort of advanced degree, because there just becomes a limit in like these larger companies of like where they're like willing to promote you to. But that being said, there's definitely other ways to go about like moving up other than through like a big company's traditional routes. And for those, I don't think it's always necessary. So I think there are options to, if you're looking at like joining a startup or some other more non-traditional roles, um, those I think allow for employers to be able to really notice the potential of their employees, and based more kind of on the individual and like their abilities, as opposed to like what degree they necessarily have. Yeah, so I think it depends a little bit. I also very much encourage people to wait until they feel like they really want to do another degree. So a lot of people feel like they have to decide right at the end of college if they want to go on to get a master's or a PhD. And I think if people feel really excited about it at that time, then great to go for it. But I think it's also not that bad of an idea to go get a job, try out different things, and then say, oh, actually, I do want more education, and decide to do that later.
Yeah. So if you had to give one piece of advice to someone who's still in high school or early in college, what would it be?
Um, I think it would be to like look around. I think it can feel very comforting and nice to feel like you're on a single track and you think you know exactly what you want to do. But I think that's actually really rare. So I would encourage people to try maybe taking a course that they didn't think they would be super excited in, that's outside their field if they have the opportunity, or maybe get involved in a club that's a little bit different from the norm that they feel like they're um, on track to be. Um, I think especially in STEM, there's a huge amount of value in being well-rounded and learning about other fields, to be able to both think more deeply about your own work, but also to be able to communicate it to others in an effective way. Because it doesn't really do us a lot of good if scientists are, diving really deep on these topics in their PhDs, but can't let anyone else know what's happening. Um, and I think it should be able to be shared. And a good way to do that is by kind of learning a little bit more outside of just the kind of typical coursework.
All right, then. Thank you for joining me on the podcast today.
All right. Thank you so much. was great.